This video explains the types and functions of sleeve fitting. So what is sleeve fitting? Generally speaking, sleeve fitting provides protection, fills gaps, and creates barriers. A protective sleeve is used to prevent damages. One type is an insulating sleeve that keeps the temperature inside from getting too hot or too cold. Sleeves are also used to fill gaps between pipes and walls that prevent air from passing through. These sleeves are usually covering water pipes because they stop water traveling up towards the floor. Some sleeves are used for barriers, such as a ring-shaped sleeve. It is used to form a hole when concrete is poured around it. The hole is used for insulation, airflow, and water flow. The different kinds of materials used to make the sleeves are iron, cast iron, stainless steel, copper, nickel, aluminum, rubber, etc. The next few slides will go further into details on the uses of sleeve fitting, such as its effects on pressure loss, how it prevents corrosion, its uses on insulation, its various construction purposes, and its role on pipe expansion and vibration absorption.
Materials in general have a tendency to undergo expansion or contraction when exposed to a certain temperature. Pipes obey these same principles, however, this can result in pressure exerted along the direction of expansion. This can lead to damage of equipment such as water heaters, where we see thermal expansion occur regularly. This is one reason why a sleeve fitting would be extremely beneficial because it can assist in the expansion or contraction of the pipe. So what would be a very suitable material for sleeve fittings? Normally, they are made with different kinds of materials ranging from metals to PVCs. But for such situations where thermal expansion comes to play, rubber fittings would be ideal. The sleeves cannot undergo a change in volume when exposed to a different temperature, because the purpose of the sleeve is to somehow absorb the expansion of the pipe, not to expand with it. This is possible in the case of rubber sleeve fittings. The elastic property of the rubber can be exploited here because when the pipes are fitted on both ends of the rubber fittings, then during the thermal expansion of the pipe, the rubber fittings would simply contract. Similarly, when the pipe goes through contraction, rubber fittings would expand to make up for the loss in length. Now, another outstanding feature of rubber fittings is that it can absorb vibrations and sounds. A typical example would be the vibrations along pipes due to heat pumps or even fans that operate within the HVACs or other AC units. And that can create problems for the pipings. A rubber sleeve fitting can reduce the transmission of such vibrations.
As previously stated, sleeve fittings can be used in many different types of pipes and systems. One such place it is used in is construction. For example, sleeve fittings are used in the making of holes in concrete walls and floors. The sleeve fitting is placed into the form and the concrete is poured on. When the concrete has dried, you are literally left with the holes that the pipe will run through. You might ask yourself why not just pour the concrete onto the actual pipe itself? Well, the answer is quite simple. The sleeve serves two purposes in this scenario. First, you may need access to the pipe in the future for replacement or maintenance. If you pour the concrete right on the pipe, the only way to get access to it would be by breaking the concrete to remove it. But this would be extremely expensive and inefficient since you would still have to pour new concrete once you're done. Secondly, the sleeve fitting also serves as a barrier between the pipe and the concrete. Why would you need a barrier? Well, because if for whatever reason, let's say flooding, the concrete absorbs water, then the pipes could be prone to corrosion. The materials that these particular sleeves are made out of are usually PVC, sheet metal, or steel.
Pipe sleeves are also useful in preventing corrosion. The sleeve acts as a protective barrier between the pipe and the environment. One example of this are heat-shrinkable sleeves, more commonly known as shrink sleeves, which have a corrosion protective coating for pipelines in the form of a wraparound that can be applied in the field. They use a 3-layer coating system. One of these is a 2-component epoxy primer, which is one of the major components of the corrosion protection system. This provides the pipe with excellent corrosion resistance. When pipelines are built, long sections of the steel pipe have an anti-corrosive coating applied to it in the factory. However, there is an encoded area at each end of the pipe known as the cutback. Shrink sleeves are applied onto the cutback so as to avoid damaging the coating when welding the pieces together. This is why they can be applied in the field. This allows the sleeves to be put on after and helps to protect those areas from corrosion.
One of the uses of pipe sleeves for construction purposes is to create a barrier between a pipe and its surroundings. Pipe sleeves that serve such purposes are often put on during construction of a building or a piping system, yet their purpose is for afterward. These sleeves protect the pipe from the environment and vice versa. The most common uses of such sleeves are for protective and insulating purposes. A protective sleeve prevents damage from accidental impacts in high-traffic areas, while an insulating sleeve is used to contain high temperatures within the pipe. Insulating sleeves are most commonly made of polyethylene or neoprene foam, since the melting point of polyethylene ranges from 120 to 180 degrees Celsius, and the burn point of neoprene is approximately 260 degrees Celsius. Since the main purpose of some pipes is to carry extremely hot or cold fluids, insulating sleeves are used to keep the heat transfer of these fluids with the environment at a minimum. On the other hand, since pipes carrying hot fluids can reach extremely high temperatures, they affect the temperature of their surroundings and can cause burns if touched. Insulating pipe sleeves protect from this as well.
A pipe sleeve used for various purposes, but one major purpose can be fire prevention in large factories and industry where pipes are carrying highly flammable liquids and gases. A leakage in any of these pipes can lead to catastrophic fire, which may destroy the entire industry. Since the sleeve will prevent fire, it has to be a high melting point. Thus, galvanized steel can be used for this purpose. What the galvanized steel will do, it will contain the chemical or gas leakage within the sleeve and stop it from spreading farther into the building, which may cause a larger scale of explosion. Elbow, tees, valve, and other fittings are necessary to a piping system for a pump. It must be remembered that fittings disrupt the smooth flow of a liquid being pumped. When the disruption occurs, head loss due to friction occurs. Therefore, if a sleeve is used, pressure losses due to such type of fittings can be compensated.
Pipe sleeve fittings are an integral and versatile component in the engineering and installation of piping systems. Their simple design allows for a wide range of uses and material composition. The simple sleeve fitting has made its way into almost every engineering system containing pipes, and this presentation on the sleeve fitting lists just a handful of its many uses in today's industries. Though their primary role is to extend the length of pipes, their use in many industries has been vital in controlling thermal expansion, mitigating vibrations, insulation, preventing corrosion, protecting pipes during construction and maintenance, and safety for the user. This concludes our presentation on the sleeve fitting.